Hello, today we'll be exploring IBM's Watson supercomputer. It is one of the most significant advancements in artificial intelligence technology in recent years. Watson first captured public attention in 2011 when it competed on the quiz show Jeopardy, defeating human champions Ken Jennings and Brad Rutter. This wasn't just a publicity stunt. It represented a breakthrough in how computers can understand and process natural language. In this presentation, I'll examine what makes Watson such a revolutionary tool, discuss its current limitations despite its impressive capabilities, and explore some concerns we might reasonably have about this technology and its implications for society. Let's dive in. What truly sets Watson apart from previous AI systems is its comprehensive approach to artificial intelligence. David Ferrucci is the director of IBM's Deep QA research team that created Watson. He explained that breakthrough is how we pulled everything together, how we integrated natural language processing, information retrieval, knowledge representation, machine learning, and a general reasoning paradigm. This integration of multiple systems allows Watson to perform at unprecedented levels. According to documentation about the system, Watson can process approximately 500 gigabytes of data per second. That is equivalent to reading through 1 million books in just 1 second. This processing power enables Watson to quickly analyze vast amounts of information and identify relevant answers with remarkable accuracy. Building on these capabilities, Watson's most impressive feature is its ability to understand natural language, the way humans normally speak and write. It doesn't just search for keywords, but actually processes queries to understand what's being asked, even with ambiguous phrasing or complex questions. Under the hood, Watson runs on IBM's Deep QA software and the Apache UIMA framework. That helps it generate hypotheses, gather evidence, and analyze data. From a hardware perspective, the system that competed on Jeopardy was powered by 90 IBM Power 750 servers containing 2,880 processing cores and 16 terabytes of RAM. Particularly valuable is Watson's ability to handle unstructured data, information that doesn't fit neatly into databases or spreadsheets. As Michelle Turner, Senior Director at Merit CX notes, the world that we live in is very unstructured. You've got social media, you've got call center notes. Most of the data within an organization is really unstructured in nature, and text analytics helps us manage that. Watson excels at making sense of this unstructured information. Watson's capabilities are not just theoretical, they are being applied in numerous industries today. In healthcare, Watson has been implemented at Kettering Cancer Center for lung cancer treatment decision support. The system has proven so reliable that according to reports from 2014, 90% of nurses who use Watson follow its guidance. In financial services, Citigroup has employed Watson to analyze customer profiles, quarterly reports, analyst reports, regulations, credit ratings, and government filings, along with online news, blogs, and even Twitter feeds to provide more comprehensive financial insights. One particularly fascinating application occurred in education. At Georgia Institute of Technology, Professor Ashok Goel created a teaching assistant named Jill Watson, powered by IBM's technology. Students in an online knowledge-based artificial intelligence class corresponded with this AI assistant all semester, asking questions and assignments and projects. The most remarkable part, the students had no idea they were interacting with AI until the professor revealed it late in the semester. Watson's text analytics capabilities also help organizations identify emerging issues in customer feedback before they become major problems. As Turner explains, structured text allows companies to spot growing trends or concerns that might not yet be reflected in structured metrics. Let's briefly look at how Watson actually functions. Rather than using a single algorithm, Watson processes information through hundreds of parallel algorithms that work independently of each other. These algorithms examine evidence from different perspectives and assign confidence scores to potential answers. What makes this approach powerful is how Watson uses contextual evidence to assess and score these possibilities, as explained by Professor Lillian Lee at Cornell University. Watson incorporates machine learning in several crucial stages of its processing pipeline. This includes reinforcement learning for strategic gameplay and machine learning techniques to determine confidence levels in its answers. The system is constantly evaluating competing interpretations of data, which allows it to achieve high confidence answers even when dealing with ambiguous or complex questions. It is this sophisticated process of examining multiple evidence paths simultaneously that makes Watson more than just a search engine. Despite Watson's impressive capabilities, it does have significant limitations. Perhaps most fundamentally, Watson lacks true emotional understanding and connection. While it can process language that describes emotions, it cannot genuinely experience them. This relates to an interesting comparison made by Jesse Hempel in Fortune magazine between Watson and the AI character Samantha from the movie Her. As Hempel notes, we don't truly know that Samantha fell in love. We do know that Samantha perfectly embodied and replicated the signs and signals of falling in love. The same is true for Watson. It can mimic the appearance of understanding, but lacks actual consciousness. Understanding context also remains challenging for Watson. During its Jeopardy appearance, Watson sometimes gave incorrect answers after wildly misinterpreting clues. This highlights how Watson's language processing, while advanced, still falls short of human comprehension in many ways. Building on these limitations, Watson continues to struggle with nuanced language and cultural context. Idioms, sarcasm, humor, and culturally specific references can be particularly difficult for the system to interpret accurately. Even more fundamentally, Watson cannot truly understand human experience despite its ability to mimic understanding. It is ultimately limited to its training data and programmed capabilities. It cannot think outside this box or develop genuine insights in the way humans can. IBM's own David Ferrucci acknowledges these limitations. He stated, "Natural language understanding remains a tremendously difficult challenge, and while Watson demonstrated a powerful approach, we have only scratched the surface." This admission from the lead researcher behind Watson highlights that despite its impressive achievements, there is still a vast gap between Watson's capabilities and true human-like understanding. Watson's capabilities raise several concerns worth examining. One significant concern is potential job displacement in knowledge-based industries. As noted in the Cold Fusion video, the obvious question is, could Watson replace expensive employees that are currently within the same area of operation? While technology has always changed employment patterns, AI like Watson specifically targets knowledge work previously thought to be uniquely human. There are also concerns about transparency and disclosure. The Georgia Tech case, where students unknowingly interacted with an AI teaching assistant, raises ethical questions about when people should be informed they are communicating with AI rather than humans. As these systems become more convincing, this issue becomes increasingly important. Another concern is over-reliance on AI for critical decisions. While Watson can process more information than any human, its recommendations still need human oversight, especially in high-stakes fields like healthcare or finance. Additional concerns include the risk of data bias influencing AI recommendations. If Watson's training data contains biases, whether related to gender, race, socio and economic status, or other factors, its outputs may perpetuate or even amplify these biases. Questions about responsibility also arise when AI makes mistakes. If Watson provides incorrect information that leads to harmful decisions, who bears responsibility? The developers, the organization implementing it, or the users who followed its recommendation? Another big concern, potential human laziness and critical thinking as we become accustomed to outsourcing analysis to AI and the limitations of AI in simulating emotional intelligence correctly. There is a fundamental gap between Watson's information processing capabilities and true understanding that must be recognized. Moving forward, we need to balance technological advancement with ethical guidelines that address these concerns proactively. Looking ahead, Watson's development continues to focus on improving natural language processing capabilities and expanding into new industries and applications. IBM's research team is working on making Watson's interactions more conversational and personalized, moving away from optimizing individual components toward improving how Watson evaluates competing interpretations using context. As for Roche envisions, the ideal future for Watson would be something like the ship computer on Star Trek, a system that can understand queries expressed in human terms and provide accurate, understandable responses. Yet achieving this vision will require ongoing advances in how AI systems learn and interact. As these technologies become more integrated into our daily lives, we will need robust frameworks addressing ethical concerns. The development of Watson represents a significant milestone in artificial intelligence, but it is ultimately a tool whose value and impact will depend on how we choose to use it and what safeguards we put in place. Thank you.